Now, the second step in creating a data narrative is presentation of the evidence. So one of the jobs that we have to do after we create a good cross-section of data visualizations to help find our insights in our data is to select, basically edit, curate, to select evidence that clearly describes new insights. So I may have created maybe a dozen different data visualizations from data about a particular subject. And what the idea is here is we might take a look at all 12 of those, 15, maybe 20 different data visualizations, and handpick that selection of data visualizations that presents the evidence and the arguments in the best way. Which ones will be the most persuasive, or which ones are the obvious insights? So we will select those frames of data visualization. And we'll talk a little bit about how do we create good frames of evidence, or good data visualization frames for a story. So in this example here, this is a way that we can highlight a particular point. So several of these examples that we're going to look at here are adapted from the book Storytelling with Data from Cole Knaflic. We'll start out here with the concept of highlighting the point. So on the top left-hand corner, we have here the cost per mile by miles driven. So this is a similar data visualization to the connected scatter plot that we discussed before. So we see here on the y-axis cost per mile, and then miles driven per month. And we see a number of plotted points here. Basically, they're all in gray. We have a particular average that's represented there. Now, when we highlight things in a data visualization, they come forward. Those are the things that stand out that our audience is going to see first. So if we look at the same data visualization, the bottom right-hand corner, only this time with highlights, the particular point that we're making in the title resonates to a much greater degree with the audience. So we're trying to highlight cost per mile by miles driven, okay? So what we see here is we've highlighted certain data points in orange, and we see there the particular average, so we have a mean line there. I'm a very strong proponent of including means or medians, some reference point in every data visualization, particularly with plotted points or trend lines. So we see that average line in there. We've left in gray everything that's below the average, but we want to highlight everything that's above the average. So we have higher cost per mile when we have a lower amount of miles driven per month. So we see that with the orange dots there to the left. And then we also have a higher cost per mile over on the right-hand side when we have a higher number of miles driven per month. So we kind of see both tails on a particular distribution there. And we use color, the orange color, to highlight the point that we're making in our data visualization there. This is the insight. So the insight here would be when you have lower than average or higher than average number of miles driven per month, you're going to have a higher than average cost per mile. Now, the next technique we'll call fading data back. Okay, so here on the left-hand side, we start off with what's known as a bump chart, basically some different categories. So we have employee feedback here from a survey, the importance of peers, culture, the work environment, leadership, career development, rewards and recognition, or performance management. And we see folks that are favorable for these particular categories. And we're looking at a particular time series of data from 2014 to 2015. So some categories increase, some decrease, so we see some movement there. But one of the things we can't really see is which one's the most important and which one are we not necessarily wanting to focus on or not highlight. And so similar to the highlighting that we did before, we might color encode career development or highlight career development, and then everything else, all the other categories, we fade back with gray. So we encode those with gray. Now, what's going to happen? What's the dynamic that occurs with the audience? Well, when we fade all the other data back, both the labels as well as the visualization encoding, our audience will focus on the thing we want them to focus on. Basically, in contrast, career development stands out as the important insight or point that we're making here. So in this particular organization, the interest in career development basically dropped from 49% in 2014 to 33% in 2015. So we could infer many things from that. Perhaps we're doing an excellent job on career development, so it's just not the highest issue or most important issue for our employees right now. Defining the action. So utilizing an example, so this is another example that we have here of a particular trend in service tickets. So this could, for example, might be the number of service tickets for an IT organization. Perhaps this is bug fixes for a particular organization, for a software program or platform, or for an IT organization on the ticket volume that came in and how many tickets they processed. We see the 12 months across the x-axis of time there, as well as the aggregate number of tickets that came in. We see different numbers like 160, 184, etc. Now, yes, for certain, the bar chart does represent the comparison between ticket volume received versus ticket volume processed. But one of the things that we're trying to accomplish with this data visualization here is to be persuasive on hiring 2 new employees to work in this particular group. So here's where we're defining the action. And so we might change the style of data visualization from that on the top left to that on the bottom right, where we see a particular trend line. So instead, we encode the data. We have pretty much the same axes on X and Y, but instead we use plotted points with a trend line connecting the plotted points in between. And we see basically the 2 comparisons over time of different data. So we look starting in January, particularly through May. Basically everything's getting taken care of. The number of tickets that are coming in, number of tickets that we received in the gray line are being fully processed by the blue line. Now, we use an annotation here to highlight a particular event. Well, 2 employees quit in May. And at this particular point in time, so this particular action of the 2 employees quitting had an impact. It basically had a cause and effect relationship on the next series of 6 or 7 months. So we see there in May, these 2 lines begin to diverge, and by the time we get to July, when we get to August, we see a significant gap in the number of tickets received at 202, and we're only processing 156 of those. And so we're starting to have a backlog of tickets that are unprocessed. And that continues through August, September, October, November, and December, where we can see the significant gap in labor to handle these particular tickets. And this is how we can use a data visualization to be persuasive. We start off with the title, please approve the hire of 2 FTEs. So we're basically defining the action that we wish. What do we want to accomplish? What's our argument? We want to hire 2 new people, so we put it right in the title. The subtitle here is basically just a reminder that 2 people did quit, so these have been open headcount positions in the organization. And then we use another subtitle here, basically to scope formally that this is ticket volume over time. And then we use the annotation basically to make the point that 2 employees quit. We don't have that labor capacity, and we're falling behind. Now, a little bit different context of communicating program results. So this is an example of how we might communicate the results of a particular program. So this might be a program about introducing science to different education levels or classes, introducing it to kids. So we start off with the visualization in the top left there. We surveyed kids before a particular program. How do you feel about doing science? And we see different responses. I'm bored with it, not great. I'm okay with it, kind of interested, or excited about it. So we have different feedbacks in different categories there. Then we introduce a particular program, telling kids about science. And then we survey them again, post, how do you feel about science? And we get some different measurements there. Now, this visualization probably works to a significant, or to some degree, but it's not quite as effective as it could be, because our comparisons of each of these categories is not side by side. We're able to effectively make that comparison. In this context, this particular comparative data visualizations provides us a comparison between the 2 wholes, but not necessarily a comparison between the individual categories that make up a percentage of that whole. So moving down to the right-hand side, reframing this in a little bit different style of data visualization, we might utilize a bar chart that compares the particular categories. So we title this, the pilot program was a success. So again, we're persuading here. We're communicating that this is our particular position. Then we ask the question, how do you feel about science? So this was the question regardless of whether it was before or after the program. This was the central question. So we don't necessarily need to repeat this twice. We just need to state it once because this was the central question we were asking. We see an annotation. Before the program, the majority of children felt it was just okay. Their feelings about science was just okay. So we see that on the left-hand side. And then we see an annotation over on the right-hand side. Note the color encoding. After this program, more children were kind of interested and excited about science. So now let's get into the comparison. So we see under board. So we use color encoding here as a before and after, gray before, blue after the treatment. And we see not too much change there, a little bit of change after the treatment, but not a lot. We see the same thing in the category of not great. So about the same there. But in okay, we see a fairly significant shift here. So 40% in the pre-survey were just okay, but only 14% were okay after. So we read on a little further. We're not too sure what to make of that yet, but then when we get to kind of interested, then it makes sense. So before, folks that answered kind of interested, we're at 25%, but then it jumps up to 30% after the program. And then most importantly, where did all these folks go from the 40% and okay? Well, we now see that only 19% were excited about science before the treatment program, but after the treatment program, we went to a full 38%, basically doubling the amount of kids that were excited about science. So this is a way that we might communicate program results, again, in a persuasive way that makes a comparison by category. Another example, using price analysis. So here we're taking a look at different prices of products. So our title here is Average Retail Product Price per Year. So we do products on the x-axis there, product A, B, C, D, and E. We have time series of different years, 2008, 9, 10 through 2014. And then on the y-axis, we have the average retail product price. And we see, say for example in blue, that encodes the product price for 2008 in each of the product categories. In 2008, we see that some of these products were available, A and B was available, but perhaps C, D, and E were not. And then we see in different years, so if we go to 2014, we see that the two products in 2014 have been available in each year. So we can make some things out from this, but this particular style of data visualization may not be the most effective. Bar charts may not be the most effective for this particular type of information representation. So now let's move to the visualization on the bottom right. Same subject, same data, so retail price over time by product. But consider the way this data is now laid out. So our axes are a little bit different here. So instead of encoding products on the x-axis, we use our arrow of time again. Why? Well, our audience expects arrow of time to be on the x-axis. So we have 2008, 9 through 2014 on the arrow of time, moving left or right on the x-axis. The average price, we leave the same. So that's our y-axis there, the average price. And then instead of the bars, we do a trend line of the price. We might plot the points from 2008 to 2014 or whatever years are appropriate for that data. And we see the trend line for particular prices. For each of these products, we can also see there's a particular average. And so once again, I'll highlight to you that we're using the mean or the average to help us make decisions here, to help us compare these different measures. What we see there is we see, so highlighted in blue is our average dot, and then we see the recommendation. So again, we're trying to persuade of here's our recommended price level for a particular product. And here is between 150 and 200, and we create that bar all the way across. Now notice that there isn't any particular data that's representing this recommended range bar. That's a human sort of judgment, decision making, but we represent that in relation to the trend lines for the different products so that anyone that we present this to, they can exercise their own judgment about the recommended price range and the different trend lines to perhaps come up with the same or a slightly different recommended range of pricing. But this helps to aid the analysis of pricing and a particular price decision that we might make. Now, let's talk a little bit about using annotations. So annotations are super important, very, very helpful to help us understand the data. Basically, they highlight how the data is changing, what's important, and what do we want our audience to focus on, okay? So this one is a little bit of a humorous data visualization. This is adapted from a visualization and data set provided by David McCandless. And it's involving peak breakup times when couples who are, I guess, boyfriend, girlfriend dating, that they break up over a calendar year. And so we see on the x-axis there January, February, March through December. So basically all 365 days out of the year segmented by months. And then we see different peaks and valleys where different individuals decide to break up their boyfriend-girlfriend status, their couples, perhaps move to a Facebook status if it's complicated or whatever. So let's take a look at some of these annotations. So we see there in February, so Valentine's Day. So we see an upward trend there, or perhaps a little peak around February 14th or perhaps February 15th or 16th. Valentine's Day, boyfriend forgot to book the restaurant. Perhaps it's equivalent, the girlfriend forgot to book the restaurant. But anyway, there was some expectation around this particular point in time. There's some dissatisfaction, and we see an uptick in breakups at that particular point in time. So what the annotation is doing here is it's pointing exactly to the place in the visualized data encoding that this particular event or dynamic is taking place. So again, sort of reflecting all the way back to week 1, we had discussed that the data is simply a reflection of the phenomenon. And what we're trying to get at in everything we're doing in data visualization, we're trying to describe the phenomenon. And so in this annotation, it's helping us get just a little bit closer to cluing in the audience that the phenomenon that's going on here around February 15th and 16th is expectations were not met. Then we get to a little bit later in March, so spring break. So there's sort of a humorous question that's asked here. Is it time for spring cleaning? Maybe I need to clean out the closet of my old boyfriend or girlfriend and move on to a new one. So perhaps it's a little bit of speculation here, but we might use an annotation here to describe that phenomenon that's occurring around the time of spring break. Or perhaps it's just folks go on a spring break trip and decide a new boyfriend or girlfriend is preferable to an old one. We get to April 1st. We see a particular spike that's coming up. And the annotation here might be, is this some kind of terrible joke that you wait until April Fool's Day to break up with your boyfriend or girlfriend? There's a pattern represented here in April, basically with peaks on Mondays, where people coming out of terrible weekends, posting their bad news that they've broken up with their boyfriend or girlfriend. Next annotation, summer holiday. So there's an upward trend at the end of June, beginning of July, through mid-July, where folks perhaps go on a summer holiday. They want to be young, free, and single, and so they might make a decision, more people to break up with their boyfriend or girlfriend in the summer. Then we see a downward trend through late July, August, perhaps September. That looks like perhaps the sweet spot to start or continue a relationship of late July through September, much more reduced rate of breakups. Then we can get to 2 weeks before the Christmas holidays. So perhaps folks need to clear their conscience. This is not the right fit for me. Maybe we're hanging out with family and those influences take hold. And we see quite a bit of breakup activity in the holidays. And then we see the actual day of Christmas Day We see a huge valley, significant valley in the data, sort of the lowest part in the year. No one breaks up with their boyfriend or girlfriend on Christmas. Perhaps everyone's way too happy, receiving gifts, maybe candies, chocolates, whatever. Just too darn happy to break up with a boyfriend or girlfriend on that day, particularly if they've come through with a gift that maybe they forgot on Valentine's Day, learning the lesson of earlier in the year. They do provide that gift, so no one's breaking up on Christmas, or at least not too many people are, relative to the other days. So hopefully this gives you guys sort of some perspective about what we're going to do with annotations. So annotations are helping us to describe, hey, this right here at this particular place in the visualized data, something's going on, and I want to tell you about it. And making the point just a little bit deeper, annotations are the story points. So as we work in Tableau, we may do it in other custom applications. Annotations help us tell the story. So here, this is particular story about an application. Maybe it's a game called Moonville. We have active users over time. So we have time represented, again, our arrow of time on the x-axis. Divided into years and months, and then we have active users on the y-axis, and we have different annotations. So we start off here September through December of 2013. We have the launch of the game. Early feedback is mixed. Number of active users doubled in the first 4 months, so it's some good news, and it's helping to describe what's going on. January through March 2014. Number of active users increased with a steeper curve. Lots of friends and family promotions. Okay. Then March through December 2014, growth was just marginal. So it was sort of a trend line. It was positive, but not like the steep growth we'd had before. And then year-to-date 2015, there was a revamp of Game Plus partnerships with social media channels. Social media partnerships were very successful, and we had a significant growth trend here. And then our final annotation here, given recent growth rate, we anticipate will surpass 100,000 active users in June. Okay, so this helps us tell a story. You can see how the annotations here guide the audience through the development of this particular software or game platform. Highlighting the important. Okay, so what we see here, we start off with bar chart, new marriage rate by education. So this was provided, so originally, it was from the Pew Research Center. It was then adapted by Cole Knaflic, basically recut this particular data visualization, and we'll explain how. So in the top left-hand visualization there, we have different categories of education. So all is on the left-hand side, then less than high school, some college, and then a bachelor's degree. So different categorizations of education. And then we've encoded the bars for different years, 8 through 12. And then we've used some labels for the high and low points, or at least different bars in these comparisons of different educational category. Now, the thing that the point that's trying to be made here is that the number of newly married adults per 1,000 marriage eligible adults, so this is a ratio, and there's an emphasis that's trying to be placed here on, education. What's important about education and marriage? How do these two variables interact? Now, it's kind of tough to see that in the data visualization in the top left. I mean, we can look close and we're making comparisons, but just like it's difficult to make comparisons in a data table, it's not easy to make these comparisons. So what we hope to do is make it easy for the audience to understand our point. So if we look at the very same thing, bottom right-hand visualization, same title, same subtitle, same categories, same style of data visualization. We have bar charts here, same years, same metrics represented, but we do change one thing. We do the fade back technique and highlight technique. The thing that we want everyone to see is that advanced education is increasing, basically, the marriage rate. That when folks are more educated, they have higher rates of marriage. We want to highlight this. So what we do is we fade everything else back. We fade back all less than high school graduates, and some college. We fade those back, and then we highlight what we want to persuade, what's important here. That if you have a bachelor's degree or more, the marriage rate is significantly above average, certainly greater than 50%. So we're highlighting what's important. We could also change the view. So coming from that same data visualization, the top left there, we move to a different style of data visualization on the right. Same title, same subtitle, but instead we use the arrow of time on the x-axis, 2008 through 2012, and then we do sort of a bump chart style visualization where we began in 2008, where that went in 2012. So sure enough, we do see a trend, particularly in these three categories of some college, high school, and less than high school, where the marriage rate does seem to be declining. But with the bachelor's degree or more, we're highlighting that while there is some decline there from 2008 to 2012 among highly educated people, they do continue to get the point that at least more than 50% of folks that are in this category decide that marriage is a better model, perhaps a better economic model for them to exist in. We also might pay some attention to improving the aesthetics. So here we look at, on the left-hand side, a particular data visualization. So this is a stacked column chart or a stacked bar chart. We see different categories by segment, so segment 1, 2, 3 through 7, the different percentages that are associated with each category, and we see a cornucopia of different color encoding here. Now, it's not too clear what the color encoding is doing and what it's helping us here other than just separate different segments. I'd also like to bring to your attention the labels on the left-hand side. So the aesthetics on this are very poor. So what this is communicating is a particular person, group, team that does not care very much about the information that they're presenting. The aesthetics and alignment, the visual alignment on these labels on the left-hand side is sloppy, and the creators of this come off looking lazy, like they don't really care about the subject that they're talking about. There's also a highlight here of distribution by customer segment, so there's some desire to highlight segments 3, 4, and 5. So they draw a box around it, and they're representing that this is at least half of our customers versus the U.S. population, which is what the point of this particular visualization is here. It may be only 30% of the U.S. population, but it's 50% of our customer base. Now let's take a look at an alternative, the bottom right hand here. Same distribution by customer segment. We're using a highlight for what we care about. So here we're highlighting in blue, but we could highlight in orange or another color. The important thing is that we highlight what we're wanting to talk about, our point. We highlight the point. What are we wanting to say? What's interesting? What's cool? What's the insight? So the insight is in segment 3, 4, and 5, we color encode those. We show that the U.S. population, those segments are 30%. And then in our customers, that is 50%. We color encode those, and then we fade everything else back to gray. And what this serves to do is highlight our point. The point that we're wanting to make here is that for the U.S. population, these three segments make up 30%. In our customer base, it's 50%. And I also want to bring to your attention the cleanliness of the labels on the left-hand side, the alignment, and how this helps to communicate more importance for segment 3, 4, and 5. We see another sort of slightly set off alignment for 1, 2, 6, and 7, slightly less important, and that helps us highlight our point. And then finally, we'll take a look at a comprehensive visual here. So this is a visualization that might have gone through a number of iterations. And in data visualization, we will often iterate a visualization many times. We'll build it once, we'll improve it, we'll go back, critique it, improve it again. And this is a finished product, if you will, of lots of iterations. So this is a particular bar chart, number of different features, A through O, and different survey feedback. They have not used this feature. They're not satisfied. They're somewhat satisfied, very satisfied, or completely satisfied. Now, our overall title is User Satisfaction Varies Greatly by Feature. So this whole frame, everything that we're looking at is how satisfied is a set of users based on that feature. Our subtitle here is different features for a particular product X. And now let's take a look at how this particular set of bars is made most useful with the annotations. Note the matching category color encoding with blue in the annotation. So features A and B continue to top user satisfaction. So we're highlighting here that users are very satisfied and completely satisfied with feature A and B. Then we move down. Users are least satisfied. So where are users not satisfied? So we highlight those in orange. Users are least satisfied with features J and N. So what improvements can we make here for a better experience? And then finally, the last point that we want to make in this visualization is that feature O is the least used, so hardly anyone uses this feature. What steps can we take to increase utilization? And there might be other points that we want to make here. Is it worth removing feature O or another set of actions that might be relevant? The third major part of constructing our visual data narrative deals with constructing rhetorical arguments. Now, there are three major rhetorical arguments originally established by Aristotle. The first, ethical. So an ethical argument basically is grounded in ethics, or what is right and wrong. Logical. So logical arguments are grounded in sort of what makes sense or what does not. And then emotional, basically an argument that has an impact on our emotions. So what I've done is I've provided for you guys a documentary example of each of the three types of rhetorical arguments. So in the first one, ethos or ethical, I'm presenting to you The Thin Blue Line, which is one of the most famous documentaries of all time. It's about the wrongful conviction of an individual for shooting a Dallas police officer. And throughout the documentary film, there is a presentation of evidence with a theme that it's wrong to falsely convict someone of a crime they didn't commit. So the thin blue line is example of an ethical argument against wrongful conviction. Now, moving on to logical, many of you guys may have heard or seen the documentary called Super Size Me. And so in Super Size Me, this is a documentary film about an individual, Morgan Spurlock, that commits to eating McDonald's every day for a month, so every day for 30 days, and he can only eat his meals at McDonald's. So breakfast, lunch, and dinner every day he'll eat at McDonald's for 30 days straight. And what the purpose here is, or the argument is, to present a logical argument against overeating. Thus the name of the movie, called Super Size Me, which is a common practice at McDonald's and most fast food restaurants. And obviously, it may not be the best idea to eat fast food every meal, every day for 30 days straight. And as sort of evidence presented throughout this documentary film, the main character, Morgan Spurlock, visits a doctor once a week and is advised on continually increasing concern among the doctor that he should stop the experiment. But, for our purposes here, we're representing this as an example of a logical rhetorical argument. And then third, emotional. So probably most of you guys have seen images. Maybe you've all been to the San Francisco Bridge. It's sort of this huge orange-red man-made structure that stretches across the San Francisco Bay. We all have a perspective that it's just this super beautiful, romantic location that we'd all like to see at some point in our life. What this particular documentary film does is it presents an emotional argument about the bridge. So one of the somewhat hidden facts about the San Francisco Bridge is that up until the last few years, it was the suicide capital of the world, and is now only exceeded by another bridge in China, but remains one of the two most dangerous and tragic locations in the world. And the documentary film basically walks us through different characters, folks that had relationships, parents, children, friends, siblings of individuals that committed suicide on the bridge, as well as one case where miraculously an individual actually lived through the experience and went through a host of very painful surgeries. So this particular documentary, The Bridge, is presenting that sort of emotional rhetorical argument that is, from a human perspective, sort of pressing on our emotions to provide an alternate argument about the bridge as something other than sort of this beautiful piece of architecture. And so to bring this into the visualization realm, particularly narrative visualization, as we can construct our data narratives, we will be most effective if we engage one of these three types of rhetorical argument. Basically, creating an ethical theme through our story, logical theme, or an emotional theme. And it is possible that we can utilize a couple of these or blend some of these, but we'll certainly be most effective with engaging rhetorical arguments. And so to give you guys maybe some starters or examples, so some starting points for rhetoric. It is wrong to do X, so fill in the blank with whatever X is. It's wrong to do X because Y, and typically Y is the argument. In this case, it's an ethical argument because we're arguing, we're discussing right and wrong. Second example, it is not moral to do X because of Y. So again, we're making an ethical argument. Next example, it is smart to do X because of Y. So this suggests a logical or smart path of reasoning or a path of action that we should do something because it's smart to do so. As well, we can with the logical rhetorical argument, we can head in the other direction. It is foolish to do X because of Y. And then lastly, the emotional. So I feel bad because X did Y. We could also turn that around. I feel great because X did Y, or any sort of interplay on human emotion there where we engage and help an audience identify with the feelings of the characters. So these are a number of rhetorical starting points that you'll want to consider as you build your data narrative. And let's talk for a couple minutes about what is narrative. So narrative is a series of events linked by cause and effect occurring in time and space. So that definition is provided by David Bordwell in the category of film. In our space, in data visualization, we want to think about these events as a data visualization. So each frame of data visualization would function as an event. And so we would create a series of those. We might link those by cause and effect, basically creating a story arc. And then I've provided another definition here of what is a plot by Paul Ricoeur. It's an integrating dynamism, basically just a dynamic action that draws a unified and complete story from a variety of incidents. And notice here that incidents is similar to events. It's the same idea. In other words, that transforms this variety into a unified and complete story. So let's take a look at that story arc and look at some different structural approaches to creating a narrative. So here we have two of the three major approaches that have been identified. The first one is the three-act play by Aristotle, where every story has a beginning, a middle, and an end. Basically, the three acts of a play. In the beginning, we set the stage. We introduce the characters. In the middle, we introduce conflict between the characters, some sort of tension, and then at the end, we resolve that conflict or tension. So that's probably the most basic story structure. We also have Freytag's pyramid that took Aristotle's three-act play and added some more complexity to it, where we'll have a beginning, a rising action, basically increasing tension or conflict in the story. In the middle, there's a maximum point of conflict called the climax. Then we'll have falling action. Basically, we're sort of bringing our audience down off the ledge from the climax, and then we'll have an ending or a resolution. And so Freytag basically has added for us two additional elements of rising action and falling action to give us more nuance and more complexity, more texture in the story. So if I'm in your shoes, I'm asking myself, okay, that's great, but but how do I do this? How do I create one of these? So what I've done for each of these story structures is I've given you an example.